started today a question trustee Singh asked about the correlation about experience and outcomes. And so how do we get better? We get better by doing this. And so our team has developed, again, these lessons that are optional. I'm going to keep saying that 1,000 times because I know I still get emails that say I'm being required to use them. So these are optional. If a teacher has a better lesson, we want them to use what they have. So all that set aside, let's start students that are on grade. Some of them might say from the can, selling peaches. So students that are on grade. Some of you told me you remember. Some of them might say from the can, as Trustee Lugo said, from the plastic little cups. So they may have never had an opportunity to touch. I'd like you to touch the peach. I'd like you to smell the peach. We could eat it, but we're not going to. Actually, I think no, it's okay, really. I'll use President Rodriguez. So the point is this. When we talk about moving concrete to abstract, concrete, there is no substitute for the real thing. When kids can smell, feel, touch, hear, how do you hear a peach? What could you do with a peach that would help kids hear it? Bite it, you could tap it, you can roll it. There are lots of things that kids can do with this. Why is this important? Because our brain research says that the more of your senses are engaged in any object or process, moves from short term to long term. So here we can help our students understand vocabulary, not because I said define the word peach. And yes, we're talking about improving vocabulary while we're doing math. So I want you to recognize that the whole goal here, and it doesn't mean it happens in one lesson, but the goal here is to go from concrete to semi-concrete. You have semi-concrete in your packet. It could be a two-dimensional, because how many dimensions are in the real peach? 3. So you could go to a semi-concrete, which could be a picture, a black and white, it could be in color. But this looks like a peach to some extent, but can I know that this is a peach if I've never seen this? Because remember that going from concrete to abstract, ultimately, kids are supposed to be able to see this and picture this, but I can't picture what I don't have exposure or experience with. So when we talk about access and why it's so important that economically disadvantaged children of color have access to these things, it's not a small thing. It's a big thing. This can make the difference between this question that we have in front of us even making sense. So then here's my semi-concrete. I could have a semi-abstract, and the total abstract would just be PEACH. When you see those letters, do those letters evoke this? That would be a literary comparison of concrete to abstract. Mathematically, when we get into the problem, a number line could be abstract. So I'm just showing you all of the different tools that we're going to get together. So what I want you to do is I want you to think for just a minute and back to your problem, our problem of practice, one more time. Mandy sells peaches at a fruit stand. I want you to close your eyes and I want you to think and picture Mandy at a fruit stand. What do you see around her? Because she's selling peaches. So what might she have around her? So on Saturday, now you can open your eyes, she sold 7 bags of peaches. So picture a bag, and you've got peaches in them. And in this case, we specifically know there are 5 peaches in each bag. So how many peaches did Mandy sell on Saturday? I'm going to give you 30 to 60 seconds to work either in your head or on paper by yourself for 30 seconds before you partner up. What would you do to solve this problem? How do you know, how can you answer the question, how many peaches did Mandy sell on Saturday? Just do it however you would do it. There are no wrong answers. Give you 30 seconds from now.
Yay.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. So now share with a partner for 60 seconds. How did you all do it the same way, or did you do it differently? So you have 1 minute. Okay. Not enough. Halfway there on time. Seconds left. 4, 3, 2, 1. Okay, now, if I were a really good teacher, which I'm not, our teachers are way better. But what we would really be doing is I would be giving you enough time to say, use this and tell me how you would come up with 1. Use these and tell me how you would come up with 1. Use these and tell me how you would come up with 1. And actually, I might even divide it up. Like I might give Trustee Foster, you have to use this to come up with your solution. Trustee Ashe, you have to use Unifix cubes to see then if you all can share different entry points into the conceptual understanding. Because everybody, especially when you say you can't use the algorithm, in other words, you can do everything except 5 times 7. Which is exactly what most of us do because that's how we were taught. But the question is, how do you visualize that? There is a misunderstanding that if you can do the abstract, you are rigorous. The truth is, if you can do the abstract and cannot work backwards to the concrete, you actually don't have conceptual understanding. And I think Trustee Foster would agree with me. And that's research-based. So, if we'll look at the screen for just a minute, what we see here is you want kids to have an opportunity to talk to you about what they saw so you can actually then change up some responses. So we can say, what if you had, what do they know? What do they anchor their thinking in? So if Mandy sells peaches at a fruit stand, on Saturday she sold 7 bags of peaches with 5 peaches in each bag. How many peaches did Mandy sell on Saturday? And then, well, some students are gonna, well, 7 groups of 10 is 70. Half of 70 is 35. Because they might be able to work with 10 easier than they can work with 5. The one that most people will use is 7 times 5. Okay, but what if I want it to be on a number line? Do I know how to use a number line to say, well, here's 5 peaches once, 5 peaches twice, 3 times, 4 times, 5. I get to 35. And the other one could be do I need to take all of these and say, here are 5 of them, here's bag number 1. Here's 5 of them, and here's bag number 2. We used to think like, oh my gosh, they have to put 5 together in bag 1. That's actually an indication that they are able to take what's written in words and actualize what the paper is saying. That's conceptualization. Now we have to take it from there to the actual abstract so that I would be able to respond to the question. So you can see that on this particular slide, we're able to demonstrate a variety of different ways in which students could do this. On the next slide, we could use either Unifix cubes, or you might also use what we call tiles. These are the semi-concrete objects that you're saying, pretend that each one of these is a peach. But remember when I started with the peach, it is going to be very difficult if I have never touched, smelled, understand a peach to say that this can represent a peach to me. When we miss that link, instead of getting a worksheet that has 25 problems on them and I'm just completing them, it's about taking one and allowing that to be the discovery of the concept. But it is very time intensive to create these. So we are learning from our teachers who submit and help us write these items, and then we utilize them and get their feedback. So on the screen you see then tiles, you see the pictures of the semi-concrete. The next slide demonstrates how we might have a conversation about 5. This could be, there are other conceptual skills called skip counting that comes from 2nd grade and even 1st grade. So if a student is struggling, I might prompt and say, what about, could we count by 5s? 5, 10, 15, 20. Kids then are able to make those connections and the representation of what this is. And so ultimately, students learn best by having engaging conversations with each other about how they've arrived at their thinking rather than getting the right answer. It's more about asking the right questions. That's how students ultimately obtain conceptualization. And I'm not sure how much of this lesson I've totally messed up because I just went off and did my own little teacher deal. And so I think lastly, maybe just that you can use these for all different levels. You can take students that seem to be like quizzing through it, and you can accelerate it. You can make it more challenging. You can change the problem to see if they understand the patterning. So suddenly I say they don't have 7 bags of 5 anymore. They have 7 bags of 6. What are you going to do? I love to see, like I'll have kids that'll say, well, all I'm going to do is I have 1 more in each of those bags, so I'm going to add 7 because there were 7 bags. And you're like, oh my gosh, they totally get number concepts. We have other kids that are going to go, I got to go back to each bag and I've got to add 1. And now I'm going to go 6 plus 6 is 12. 12 plus 6 is 18. And they're going to continue to do that. One is not better than the other. Now, the more that they access the different strategies, that is when they can see a problem and they can find a different solution. That's actually what we want. We don't want every kid responding. We want them to get the right answer, but we want them to do it through what is meaningful, relevant, and the way in which their brain works, rather than, here's an exemplar of what student looks like. We've seen this happen too. We give an exemplar of, this is how one student solved it, and then the teacher's teaching, do it like this and like this and like this. We want this to come, we guide the process and we facilitate it. So, lots of ways in which we can anchor, we can do, the other last thing I'll say is, this is also excellent. We talked about students of color, we've talked about economically disadvantaged, students who have different languages, Spanish, of course, being the most popular. That's why representation is so important, because we can do math without knowing English. I can use these items to represent what it is we're talking about. So that's my story. I'm sticking to it, and now we can take questions, of course, from our board.
Thank you, Dr. Elizalde. Trustees, now is the time for us to ask questions on the